Hello friends, welcome to the virtual lab of 90 plus My Tuition app. Let's move on to the next inorganic salt analysis. In inorganic salt analysis, we identify the basic radical and acidic radical. So first, let's see what is basic radical and acidic radical. Well, the radical that carries positive charge is called basic radical or cations. And the radical that carries negative charge is called acidic radical or anions. Now let's see what all the equipments we needed for conducting this experiment. Test tube, boiling tube, test tube stand, Bunsen burner, beaker, dropper, watch glass, filter paper, given salt, wash bottle, spatula, test tube holder, platinum wire, glass rod, etc. As we know, for conducting an experiment, we must follow some steps, right? Yes. Let's see what are they. So the first step is preliminary examination. And the second step is analysis of acidic radical, that is anion. And the third step is analysis of basic radical, that is cation. And the final step is result. So these are the steps we need to follow. Friends, let's start our experiment. Preliminary examination. So first, we should conduct the preliminary examination of the given salt. To record each and every experiment that we conduct, let's consider a box. This contains experiment, observation and inference. First, we should note the color of the given salt. As you can see, the given salt is white in color, right? This shows the absence of copper ion, nickel ion, ferric ion, ferrous ion, manganese ion and cobalt ion. Now let's identify the smell of the given salt. For this, take a watch glass and to this add a pinch of given salt. Now add 2 drops of distilled water. Then rub it well using a glass rod. After rubbing, note the smell of the given salt. Well, can you feel any smell here? No, right? This means there is no characteristic observation and it shows the absence of ammonium ion. Now let's conduct the flame test of the given salt. For this, take a watch glass. To this, add a little amount of given salt and then add a few drops of concentrated hydrochloric acid. Then, using a platinum wire, make the salt into a paste form. Now, introduce a small amount of paste to the flame using a platinum wire. Then, note the color of the flame. Friends, can you observe any change in the color of the flame? No, right? This means there is no characteristic observation and it shows the absence of barium ion, strontium ion and calcium ion. So these steps that we have conducted are called preliminary examination. After preliminary examination, let's find out the acidic radical, that is anion, present in the given salt. For this, we will conduct the identification test for anions. That is analysis of identification test for anions. In this section, we will conduct 5 tests. From these 5 identification tests, we can identify the anion present in the salt. So the first identification test is action of dilute hydrochloric acid. To conduct this, take a test tube. To this test tube, add a little amount of given salt and then add a few drops of dilute hydrochloric acid. Then shake it well. Well, can you observe any changes here? No. it means there is no characteristic observation and it shows the absence of carbonate and sulphate ion. Now let's conduct the second identification test, that is action of dilute H2SO4. To conduct this, take a watch glass. To this, add a little amount of given salt. Then add a few drops of dilute sulfuric acid. Now mix it using a glass rod. Then note the smell of the salt. Well, can you feel any smell? No. This means there is no characteristic observation and it shows the absence of acetate ion. Now let's move on to the next identification test, that is action of concentrated H2SO4. For this, take a clean and dry test tube. To this, add a little amount of given salt and then add a few drops of concentrated sulfuric acid. Then heat the test tube. Can you observe any change here? No. This means there is no characteristic observation and it shows the absence of chloride ion. Moving to the next identification test, that is action of concentrated H2SO4 and vapor bowl. For this, take a clean and dry test tube. To this, add a little amount of given salt. Now, add a few drops of concentrated H2SO4. Then, heat the test tube. When the solution gets boiled, introduce a paper bowl into it. Can you observe any change here? Yes, as you can see, a reddish brown vapours gets evolved from the test tube. Then what does it show? Yes, it shows the presence of nitrate ion. Then what about the chemistry behind this reaction? Come, let's see. Here, the nitrate ion present in the given salt reacts with concentrated H2SO4 to form nitric acid. And the chemical equation is NaNO3 plus H2SO4 gives NaHSO4 plus HNO3. And the carbon present in the paper bowl reduces this nitric acid to form brown nitrogen dioxide. And the chemical equation is 4HNO3 plus carbon gives 4NO2 plus CO2 plus 2H2O. Moving to the next identification test, that is action of barium chloride solution. To conduct this, take a clean test tube. To this, add a little amount of given salt. Then add a few drops of distilled water. Now add a few drops of barium chloride solution. Well, can you observe any change here? No. This means there is no characteristic observation and it shows the absence of sulphate ion. From all these identification tests, we understood that the given salt contains nitrate ion. Now let's conduct the confirmatory test for anion. That is, analysis of confirmatory test for anion. The first confirmatory test for nitrate ion is brown ring test. Do you know what is brown ring test? Let's see. For doing this, take a clean and dry test tube. To this, add a little amount of given salt. Now let's add a few drops of distilled water into this and shake it well. Followed by this, add equal volume of freshly prepared ferrous sulphate solution. Wait. Do you know why we use freshly prepared ferrous sulphate solution? Well, we use freshly prepared ferrous sulphate solution because the ferrous sulphate reacts with oxygen in the atmosphere and readily undergoes oxidation to form basic ferric sulphate, which is unsuitable for this reaction. Friends, then slowly add concentrated sulfuric acid along the side to the bottom of the test tube with the test tube tilted, which contains the mixture of sample and freshly prepared ferrous sulphate solution. As you can see, a brown ring is formed at the junction of two layers of acid solution and aqueous solution. This brown ring confirms the presence of nitrate ion. Then what about the chemistry behind this? Well, the brown ring is formed due to the formation of nitrous of ferrous sulphate. Here, the nitrate ion present in the given salt reacts with concentrated H2SO4 to form nitric acid. And the chemical equation is NaNO3 plus H2SO4 gives NaHSO4 plus HNO3. In the presence of H2SO4, the nitric acid reacts with ferrous sulphate solution to give nitric oxide. And the chemical equation is 2HNO3 plus 3H2SO4 plus 6FeSO4 gives 3Fe2SO4 thrice plus 2NO plus 4H2O. Then this nitric oxide reacts with ferrous sulphate to form nitrous of ferrous sulphate, and the chemical equation is FeSO4 plus NO plus 5H2O gives FeH2O 5 times NoSO4. So now you have understood what is brown ring test. Let's move on to the second confirmatory test. For this, take a test tube. To this test tube, add a little amount of given salt. To this, add a few drops of sodium hydroxide solution. Then heat the solution. While heating, add a few amount of zinc dust. Then what do you observe here? Well, there evolves a colorless gas with the smell of ammonia. Now, take a glass rod and then dip the glass rod in the concentrated HCl. Then introduce this to the mouth portion of the test tube. What will happen? Yes, a dense white fumes formed there. It confirms the presence of nitrate ion. Then what about the chemistry behind this reaction? Here we have seen a colorless gas with the smell of ammonia, right? This is due to the formation of ammonia gas. Here the zinc dust reduces the nitrate ion present in the given salt to form ammonia. And the chemical equation is NaNO3 plus 4Zn plus 7NaOH gives NH3 plus 4Na2ZnO2 plus 2H2O. Friends, do you remember the white dense fumes formed when we introduced that glass rod that was dipped in the concentrated HCl? Yes, it is due to the formation of ammonium chloride. Here, the ammonia reacts with concentrated HCl to form ammonium chloride, and the chemical equation is NH3 plus HCl gives NH4Cl. Now we know which anion is present in the given salt. That is, the given salt contains nitrate ion as the anion. So now we will find out the basic radical present in the given salt. That is the analysis of identification test for cations. First we will make the salt solution. For this, take a boiling tube. To this, add a little amount of given salt. Now add a few drops of distilled water. Then shake this boiling tube till the salt is soluble in the distilled water. Now the salt solution is ready. Using this salt solution, we can conduct the further test. Friends, as we know, cations are classified as 0 to 6 groups. All these cations have group reagents. Like the group reagent of 0 group is sodium carbonate solution. The group reagent of first group is dilute HCl. The group reagent of second group is dilute HCl and hydrogen sulphide. The group reagent of third group is ammonium chloride and ammonium hydroxide. The group reagent of fourth group is ammonium chloride, ammonium hydroxide and hydrogen sulphide. The group reagent of fifth group is ammonium chloride, ammonium hydroxide and ammonium carbonate. The group reagent of sixth group is ammonium chloride, ammonium hydroxide and disodium hydrogen phosphate. So let's start the analysis of cations using this prepared salt solution. Now let's conduct the analysis of zero group cation. For this, take a test tube. To this test tube, add a little amount of salt solution. Then add a few drops of sodium carbonate solution. Can you observe any changes here? Yes, a precipitate is formed in the test tube. This shows the absence of zero group cation. Let's start the analysis from first group to the sixth group. For this, take a test tube. To this test tube, add a few drops of salt solution. As we know, dilute HCl is the group reagent of first group cation. So, add a few drops of dilute HCl to this test tube. Can you observe any changes here? Yes, a white precipitate is formed in the test tube. This shows the presence of group 1 cation. Now let's conduct this centrifugation. But why are we centrifuging this solution? Or what does it mean by centrifuging a solution? Well, it is used for separating the solid particles disposed on the liquid medium. After conducting centrifugation, transfer the filtrate into another test tube. To this filtrate, we will add group reagents of group 2 cations. As we know, the group reagents of group 2 cations are dilute HCl and hydrogen sulphate gas. As we know, we have already added dilute HCl to this solution. So now let's pass hydrogen sulphate gas through this filtrate. Well, can you see any precipitate here? No, it means there is no characteristic observation. And it shows the absence of group 2 cations. Now let's take a test tube. To this test tube, add a few drops of salt solution and then add a few drops of concentrated nitric acid and then heat this solution. After heating, add the group reagents of group 3 cations. As we know, the group reagents of group 3 cations are ammonium chloride and ammonium hydroxide. To this, add a few amount of ammonium chloride and then add an excess amount of ammonium hydroxide. Can you observe any change here? No, it means there is no characteristic observation and it shows the absence of group 3 cation. To this solution, now let's add the group reagents of group 4 cations. As we know, ammonium chloride, ammonium hydroxide and hydrogen sulphide are the group reagents of group 4 cations. We have already added ammonium chloride and ammonium hydroxide to this solution. So, to this same ammoniacal solution, let's pass hydrogen sulphate gas. Can you observe any changes here? No, right? This means there is no characteristic observation and it shows the absence of group 4 cations. Now let's conduct the analysis of group 5 cations. For this, take a test tube. To this test tube, add a little amount of given salt solution. As we know, ammonium chloride, ammonium hydroxide and ammonium carbonate are the group reagents of group 5 cations. To this solution, add ammonium chloride and then add an excess amount of ammonium hydroxide solution and then add a few drops of ammonium carbonate solution. Well, can you find any changes here? No, it means there is no characteristic observation and it shows the absence of group 5 cations. Since the group 5 cations are absent here, let's conduct the test for group 6 cation. For this, take a test tube. To this test tube, add a little amount of salt solution. As we know, ammonium chloride, ammonium hydroxide and disodium hydrogen phosphate are the reagents of group 6 cation. So, to this solution, add ammonium chloride and then add an excess amount of ammonium hydroxide. Then add a few drops of disodium hydrogen phosphate. Can you observe any changes here? No. It means there is no characteristic observation and it shows the absence of group 6 cation. So, we understood that the given salt contains group 1 cation. The cation present in the group 1 is lead ion. Well, the group 1 cations are precipitated as chlorides. So, here the lead ion precipitated as lead chloride and the chemical equation is PbNO3 twice plus 2HCl gives PbCl2 plus 2HNO3. Now let's conduct the confirmatory test for group 1 cations, that is analysis of confirmatory test for group 1 cation. For doing this, take the residue of group 1 cation, that is the white precipitate. Then add a few drops of distilled water into this. Then boil this solution. As you can see, the white precipitate gets dissolved in the water. Now divide this solution into two parts. Using this solution, we will conduct the confirmatory test. The first confirmatory test for lead ion is potassium iodide test. To conduct this test, take first part of this solution and then add a few drops of potassium iodide. As you can see, a yellow precipitate is formed in the test tube. Now add a few drops of distilled water into this. Then heat this solution. Do you see that? The yellow precipitate formed in the test tube will get soluble in the water. Now cool this solution. Do you observe anything here? Yes, it is reappeared as shining crystals or golden spangles. So it confirms the presence of lead ion. Then what about the chemistry behind this reaction? Let's discuss. The yellow precipitate formed here is lead iodide. The lead ion present in the given salt reacts with potassium iodide to form lead iodide. And the chemical equation is PbCl2 plus 2Ki gives PbI2 plus 2KCl. Now let's conduct the second confirmatory test for lead ion, that is potassium chromate test. To conduct this, we will use the second part of the solution. To this solution, add few drops of potassium chromate solution. As you can see, a yellow precipitate is formed in the test tube. This confirms the presence of lead ion. Now let's discuss the chemistry behind this reaction. Here the yellow precipitate formed is lead chromate. The lead ion present in the given salt will react with potassium chromate to form lead chromate. And the chemical equation is PbCl2 plus K2CrO4 gives PbCrO4 plus 2KCl. So we have identified the cation present in the given salt. The given salt contains lead ion as the cation. Now let's discuss the final step, that is result. The given salt contains lead as the cation and nitrate as the anion. Therefore, the given salt is lead nitrate.